Hello, welcome to a new section of the course, Building Real-Time Recommendations with Neo4j. In this section, we'll start with discerning different graph databases. We'll then learn about Neo4j and build our first graph. We'll learn Neo4j Windows and Linux installation. Then we'll start building our recommendation engine and generating recommendations using Neo4j. We'll also look at collaborative filtering using the Euclidean distance and cosine similarity. So, let's start with the first video, discerning different graph databases. In this video, we'll understand the concept of databases and where to apply them. We'll look at labelled property graphs and also understand graphDB core concepts. The world we live in is a big interconnected place. Anything and everything that exists in this world is connected together in some way. Relationships and connections exist among the entities that inhabit this world. The human brain tries to store or extract information in the form of networks and relations. Perhaps this is a more optimal way of representing data, so that storing and retrieval of information is fast and efficient. What if we have a system that works in a similar way? We can use graphs. They are a systemic and methodical approach to representing data. Before we move ahead with this section, it's essential to understand the background and necessity of graphs. Graphs are found everywhere in today's world and are one of the most efficient and natural ways of working with data. Graph can represent how two or more real-world entities, represented as nodes, are connected to each other. We also learn how each of them are related to the other and how this helps to communicate information in a fast, efficient visual way. Since graph systems allow us to express anything in an expressive, structured way, we can apply these systems across domains such as social networks, medicine, science and technology, and many more. To better understand graph representations, we can take a look at examples of networking on Facebook. Let's assume there are three friends, John, Paul and Krish, connected on Facebook. John, Krish are mutual friends. Paul, Krish are mutual friends, and Paul is a friend of John. How do we represent this information? Take a look at the diagram. Don't we feel that this representation is one of the most efficient and natural ways of representing data and its relations? John, Krish, Paul are nodes representing user entities, and friend of arrows are edges which represents the relationships between the nodes. We can also store the demographic details of user nodes, such as age and details of relationship, such as friends since, as properties in the graphs. By applying graph theory concepts, we can find similar users in a network or suggest new friends to users within the friends network. We shall learn more about this later. Graph databases have revolutionized the way people discover new products and share information with one another. In the human mind, we remember people, things, places and so on as graphs, relations and networks. When we try to fetch information from these networks, we go directly to the required connection or graph and fetch the information accurately. In a similar fashion, graph databases allow us to store the users and product information in graphs as nodes and edges, relations. Searching a graph database is fast. A graph database is a type of NoSQL database that uses graph theory to store, map and query relationships. Graph databases excel at managing highly connected data and managing complex queries. They are mainly used for analysing the interconnections between data. Here, the priority is given to relations, so that we don't have to bother with the foreign keys, as in the case of SQL. Graph databases mainly consists of nodes and edges, wherein nodes represent the entities and edges the relationships between them. The edges are directed lines or arrows that connect the nodes. In the diagram, the circles are the nodes that represent the entities, and the lines connecting the nodes are called edges. These represent relationships. The orientation of arrows follows the flow of information. By presenting all nodes and links of the graph, it helps the users get a global view of the structure. Neo4j, FlockDB, Allegro Graph, graphDB and Infinite Graph are some of the graph databases available. Let's take a look at Neo4j, one of the most popular among them, made by Neo Technology. Neo4j is so popular because of its strength, swiftness and scalability. It's mainly implemented in Scala and Java. It's available in both the Community and Enterprise editions. The Enterprise edition has the same features as the Community one, with additional features like enterprise-grade availability, management and scale-up and scale-out capabilities. In the case of RDBMS, the performance degrades exponentially as the number of relations increases, whereas in Neo4j it's linear. The image shown on screen depicts the various graph databases. So, we've seen an example of a social network representation of three friends. This graph representation of data, which contains directed connections between entities, nodes, relationships between nodes and properties associated with nodes and relationships, is called a labelled property graph model. A labelled property graph model has the following properties. Graph contains nodes and relationships. Nodes may contain properties, key value pairs. Nodes may be labelled with one or more labels. Relationships are named and directed and always have a start and end node. Relationships may also contain properties. Let's understand the graphDB core concepts. Here are all the elements. Nodes. Nodes are the fundamental unit of a graph. Nodes are the vertices in the graph. It mostly refers to the main object that is being referred. Nodes can contain labels and properties. From the story, we can pull 3 different objects and make 3 nodes. 2 of those are for friends, and the other is for movie. Labels. Labels are a way to differentiate between the same kinds of objects. Labels are generally given to each node with similar characteristics. Nodes can have more than one label. In the example story, we gave labels of person and movie. This optimized the graph traversal and also helped in logically querying the model efficiently. Relationships. Relationships are the edge between 2 nodes. They can be unidirectional and bidirectional. They can also contain the property for which the relationship is being created. Relationships are named and directed and always have a start and end node. For example, there is a relationship of friend of between 2 friends. This shows the connection between different nodes. There is also a relation of has watched between each of the friends with the movie node. Properties. Properties are the key value pairs. Properties can be used for both nodes and relationships. They are used to say the details about a particular node or relationship. In the example, the person node has properties of name and age. These properties are used to distinguish different nodes. Relation has watched also has the properties of date and rating. In this diagram, John, Krish and Paul are nodes that are mapped as user labels. Also observe the edges that show relations. Both nodes and relations can have properties to further describe them. In this video we looked at different graph databases.